Hi, today we are on pages 7 and 8 in our notes. We are going to review what a proportional relationship is. We talk about proportional relationships in 7th grade, so we are going to touch base on them because we talk about non-proportional relationships in 8th grade. So we're just going to talk about this for today. So please have page 7 and 8 out. Again, I'd probably have a calculator. If you do not have your notes with you, you can click on here and either print them, or if you have downloaded Kami, you can download it and notate on your Chromebook. Okay, so we're going to do a little bit of vocab real quick. So a proportional relationship is when two quantities have a ratio that are equivalent. Equivalent just means equal or the same. So if we have two quantities with a ratio that are the same, we would call them proportional. When we look at a graph of a proportional relationship, they do two things. The first thing is that it will be a straight line. And that is because it is a constant equal relationship. And the graph will also pass through the origin. So if we're looking at a graph of a proportional relationship, it should start at the origin or cross through the origin. So that would be 0, 0. And that would also be the reason why we would have an equivalent ratio. Okay. If we're looking at a table, if we want to check for equivalent ratios, that would tell us if it's proportional or not. So in other words, in a proportional table, if we compare the ratio of y to x, it will always be equivalent or the same. Okay, so we're going to practice a few problems. We're going to have this problem, we're going to represent it with a table, we're going to represent it with a graph, just to understand this concept. So Hillary is looking for a gym to join. One gym offers a membership of $25 a month. Use this information to complete the following. So first, we're going to complete a table. Complete the table to show the relationship between the number of months at the gym and the total cost of the membership. Okay, so we have the number of months, which is our X, okay, and the cost is our output. So we have our input, which is the number of months that Hillary can be working out at the gym, and the output would be the cost. Okay, so when she opens her gym membership, and she has been there for 0 months, okay, she doesn't have to pay any money. So 0 months, $0. Okay, if she's there for a total of 1 month, okay, that means $25 a month. That would be 25. Okay. If she was there for a total of 2 months, we'd have to add another $25 for a total of 50. 3 months, we'd have to add another 25 for a total of 75. 4 months, an additional 25 for it to be 100. Okay. So before we can talk about what we're going to put right here, we just need to talk about this process. Okay, so basically we're adding 25 every single month. Okay, another way of adding 25 every month is multiplying by our input. So for this one, 25, it has happened 0 times, and 25 times 0 is 0. Okay, for 1 month, we did 25 times 1, and 25 for 1 month is 25. 25 for 2 months is 50. 25 for 3 months is 75. 25 for 4 months is 100. So this process is we're taking the 25, okay, and we're multiplying it by our input. So if we don't know the input for this case, we would put 25 times x. And whatever that output is will be our y, or our output. Okay. So the first question for the table is, what is the slope or rate of change shown in the table? Okay, so our slope, we calculate slope by the change in our y over the change in our x's. Okay, so we can pick any 2 of these points. Why not just pick the first 2? Okay, so the change in the cost from 0 to 25 is $25. Okay, so the change in the y is 25. Okay. And the change in the x to go from 0 months to 1 month is plus 1 month. Okay, so the slope or the rate of change is 25 for every 1, or just 25. Okay. is the table proportional? So to check if a table is proportional, we can look right here. We would have to check our ratios y to x, and if they are equivalent every single time, we would call that proportional. Okay, so 0, 0 is the only one we don't count, okay, because 0 divided by 0 is a really weird thing. Okay, so first we're going to check our y to our x, so 25 to 1. Okay, then we're going to compare 50 to 2, 50 to 2, 75 to 3, and 100 to 4. Okay? Those are all of our y values over our x values. And if we notice, all of these ratios are equivalent to 25. So this table is proportional because all of our ratios, are equivalent to 25. All right, so now it's asking us to use our table of values to create this graph to show our relationship as well. So we have our inputs and our outputs, and now we're going to just basically put that on this graph, okay? These are our x values, okay? This is our x-axis, so I'm going to label it with months. Okay, these are my y values. This is my y-axis, so I'm going to put cost. Okay. All right, so now I'm just going to plot these points. 0 months, $0 or 0, 0. Okay. 1 month, $25. So 1 month, 25 would be in the halfway. 2 months, $50. 3 months, $75. 4 months, $100. Okay, so those are our 5 data points. And because it would continue on, we don't know if Hillary's going to go to the gym for 4 months or 12 months, we will put a straight line and then we will put an arrow at the end to say that it will continue on. Okay, the reason we won't put an arrow down here is because we can't go back in time and have negative months. So, all right. The first question for the graph is, what is the slope or the rate of change in the graph? Okay, so we've been talking about slope a lot, and the first thing we talked about with slope was the rise to the run. Okay, so we have to pick 2 good points, and let's find the slope of them. Okay, so this is a good point, and I mean, we technically know that point, but we don't think that's probably a good point, so let's use this point. Okay, so now we're going to find the rise compared to the run. Okay. Looks like it goes up 10, 20, 30, 40, 50. Okay, and it goes over 1, 2. So the rise is 50 for every time it has a run of 2, which is equivalent to 25 to 1 or just 25. All right, the other question is this graph proportional? Well, in the table, we already said that it is proportional because the ratios are always equivalent to 25. Okay. The definition for proportional when we look at a graph just says the same thing. If we have a straight line that passes through the origin 0, 0, it is proportional. So this is a straight line because it was constant and it started at 0. So it is proportional for a different reason, but they do mean the same thing. It has a straight line, okay, which means that it will have an equivalent ratio, and it begins or it crosses through 0. Okay. So now it says to write an equation on page 8 to represent the relationship between X, the number of months at the gym, and Y, the total cost. Okay, so we actually kind of already did this in our table. So right here, we took our input, X, and multiplied it by 25. And whatever we did, we would get our output. Okay, so our equation could be written as Y equals our output equals $25 every input, every month. Okay? Part B says, do you see the slope in the equation? If so, where? Well, it's right there, so yes. And it looks like it's being multiplied by X, or our input. Okay. What conclusion can we make about proportional equations? Well, it's going to be Y equals our slope times X. Okay, so definition: proportional equations can be written in the form y equals mx, where m represents our slope. I don't know why they use the letter m, but they'll always use the letter m for slope. It's very strange. Okay, what do the x and the y represent in the equation? Okay, so the x will represent our input, okay, and the y will represent our output. So it'll depend with word context problems, but we'll look at another problem. Okay. The table shows the cost of a certain number of pounds of apples. So we have the pounds of apples and we have the cost. So the first thing in an entry of a table is our input, and the second thing is our output. Okay. So part A says, what is the slope or the rate of change? So we need to find the change in the y compared to the change in the x. Okay, so we need to figure out how we go from 552 to 1104. So I'm going to grab my calculator and I'm going to subtract 1104 minus 552. Okay, and I get 552. So the cost is 552. That's the change. Okay. And the change in the pounds to go from 4 pounds to 8 pounds would be 4 pounds. So the change in the x is 4. Okay. So now I'm going to divide those two, and I get 138 to 1, or just 138. Okay. So now it says, is the table proportional? How do we know? So to check if something is proportional, we need to compare. Okay, again, it's on the front page. Okay, if something is proportional, the ratio y to x in a table will be equivalent. Okay, so I am going to set up some ratios. I'm going to set up 552 to 4, 1104 to 8, 1656 to 12, and 2208 to 16. Okay, and if they are proportional, they should all be equivalent. So 552 divided by 4, I get 138. 1104 to 8, I get 138. 1656 divided by 12, I get 138. And 2208 divided by 16, I get 138. So just looking at these ratios and simplifying them, they are proportional because all of them have a rate of 138. Okay? Because of this, we can write an equation. Okay? The equation is just y equals our slope times our input x. So our slope is 138 times our input x, and that is our equation. Okay, number 2 says to use the graph to answer the questions. Okay, so this has no context. It doesn't talk about pounds, doesn't talk about cost, so we just have this graph. Okay, so it asks, what is the slope or the rate of change? So we have a graph, so we need to find the rise compared to the run. Okay, so to do that, we need to pick 2 good points. So I like to use that point if it's there, okay, and I like to pick the next closest one. That's not perfect, but this one's perfect. Okay, so now I'm going to find the rise up 2 boxes, but we're going by 2, so the rise is 4. Okay, and the run is 1, 2, 3 boxes, and we're going by 1, so the run is 3. Oops. Okay. And I can't simplify 4 to 3. We want to keep it as a ratio, so the slope is 4/3. Okay. Part B, is the graph proportional? How do you know? Okay, again, if we look at our notes, if you look at a graph, if it is a straight line and it passes through the origin, it's proportional. So it is straight, so it is constant. It starts at 0, 0, or it starts at the origin. So yes, it is proportional because it is straight. And it passes through the origin. Okay. Then it says to write an equation for the graph. So to write an equation, we write y equals our slope, which we calculated to be 4/3, times our input x. So that is our equation for a proportional relationship. Okay, so for tomorrow's at-home practice, there will be a go formative. You can start it today if you'd like, but you don't have to.